Okay, here we are. Michael Michelin Mills. Nice to see you guys. Been a while. 6 years. Who's counting? So, I've always wanted to continue the videos that I was doing back then, and I finally gotten an opportunity to do so. And in today's video, which starts the series all over again, but we're going to continue on through and hit about as much as we can when it comes to the steel industry. So today we're going to talk about stainless steel and all the different types of stainless steel. An ordinary, everyday experience shows us that steel corrodes. Give it moisture and oxygen, and it'll form rust. Rust is porous, and it will continue to grow and flake until ultimately consuming all of the steel. But add enough chromium to the steel, and it has the effect of allowing only a thin layer of oxide to form, which does not allow the corrosion to continue. Depending on the amount of the chromium in the alloy and the effects of some other elements, various compositions have been established with a variety of combined characteristics known as the standard alloys. Specific environment, temperature, strength required, fabricability, and ultimately cost are all involved in selecting which stainless steel is used in any given application. Stainless steels are classified as austenitic, ferritic, martensitic, duplex, or precipitation hardened, and which is all based on their metallurgical structure. To start, we're going to talk about the austenitic stainless steels, and those are the 200 and 300 series. They are not hardenable by heat treatment, and heat treatment depends on a change in structure with a change in temperature. And these grades remain austenitic from high temperatures up to 1900 degrees Fahrenheit to very low cryogenic temperatures of 300 below. There is little or no response to a magnet under normal conditions. However, cold working can make these materials slightly magnetic. And the common types, known generically as 18-8, and that means there's a nominal amount of chromium and nickel at 18% chromium and 8% for nickel. And those grades are 303, 304, and 316. 316 has a little molybdenum, which boosts the corrosion performance as compared to 304 in many of the environments. In addition, 316 has more oxidation resistance at higher temps. Type 303 has sulfur added, which improves the machining characteristics but sacrifices some of the performance. Annealed condition is the most common and is most corrosion resistant. And they all exhibit good strength, toughness. In cryogenic applications, they perform well. Next is ferritic stainless. Some of the AISI 400 series alloys are not hardenable by heat treatment, as these grades remain ferritic over the critical temperature range. Some of these grades, they respond to a magnet much like ordinary steel. There are two straight chromium grades, those are 405 and 409, with relatively low chromium. They're used in auto exhaust applications where appearance is not important. However, higher chromium alloys like 430 resist corrosion at higher temps, and they maintain a better cosmetic appearance for automotive applications or appliance trim at a lower cost than the austenitic grades. And again, annealed condition is most corrosion resistant. Next is martensitic stainless steel. That consists of the balance of the 400 series, and they are hardenable by conventional heat treatment. Heat treatment is similar to heat treating alloy steels. They have an austenitic structure at high temperature and will transform with rapid cooling to a martensitic structure. They are typically used in a fully hardened condition for the best corrosion performance alongside having high strength and hardness. Depending on type, and that can be anywhere from a mid-30s RC, which stands for Rockwell C, a mid-30s RC hardness for types 410 and 416, all the way up to a 60 RC for type 440C, which is heat treated. Maximum hardness is dependent on carbon content. Achievable hardness increases with carbon content. These types also respond to a magnet, like the ferritic. pH stainless, the 600 series, stands for precipitation hardening, and that means they are hardenable by heat treatment. They also typically respond to a magnet. Most common alloy in that series is 630, which is also known as 17-4. and the heat treatment consists of a high temperature solution treatment, aka annealed or solution annealed, followed by an aging at temperatures between 900 and 1150 degrees Fahrenheit. Strength and general corrosion performance is higher with aging at 900. Strength is reduced with higher aging temperature, but toughness increases. Corrosion performance also improves for some specific environments, and strength and corrosion performance are both considerations for these grades. Lastly, duplex stainless steel. And these are the stainless steels with a mixed structure of austenite and ferrite, and they are used in more specific applications than this introduction is going to cover. Stay tuned, and we will get back to the duplex grades. Many of them are proprietary names, and few, like 2205, are considered standard or common grade designations. So that wraps up our discussion on stainless steel today. I really hope you enjoyed it. And over the coming weeks, I'll be discussing the types again, but in more detail. 300, 400, pH, duplex, 200. And make sure to subscribe. Hit that little button. Make sure to subscribe and stay tuned. This is Michael with Michelin Metals. Appreciate you guys watching. Thank you.